Now we'll see some more ways to solve Diophantine equations. So first is the method of factorization, and second is to make whole squares or to create whole squares. Okay, so let me just quickly tell you how this method are going to be used. Say we are supposed to find the solution of this equation. Say a into b is 6, where of course a and b belongs to, say, integers. Yeah, say normally you will be given either integers or you will be given a b belongs to natural numbers. Mostly these two options will be given to you. For now, let's take this case. AB belongs to natural number. Okay, so here what can be the choices of A and B can be? Well, let's make a table here quickly. We see we can have A as we can take A 1 and B then can have to be 6. A can be 2, then B have to be 3, and we can take the other way around, 6 1 3 2. I think these are all the possible cases or possible solution that we are going to get out of this Diophantine equation. And if A and B were to belong to this set, then we would also have to take -1 -6, because multiplying this will give us 6, and we'll also have -6 -1 -2 -3 -3 -2. So we'll have these many solutions, 4 here and almost 4 here. So we'll have 8 solution to this Diophantine equation. So this is how the method of factorization going to work. And we always want a number on the right hand side. Say if here was, say if we had, just a sec, say if we had A, B is 6C, some other integer C. Now we can't see anything. We don't know what A could be, what B can be. You may say you can take A to be 6 and B to be C, because this is very well can be true, no problem. You can also say 2 3C. Yes, this can also be a solution, but for this way you cannot have multiple cases, many cases, because we don't know how many prime factors C has. Suppose C turned out to have these many factors. Suppose C had 2 3 4 5 7, then how many cases are we going to deal with? So it's gonna get little onerous, so very difficult this way. So if we only want a number to be on the right hand side, be very careful with this. We always remember it. We always want a number on the right hand side. If we can't get a number, we'll try to do some other thing. We'll try to choose or try to do it with some other method. And now say here, let's take one more example. Let's say we had A into B were given to be 12, say 12. So again we can make the table. We'll get 1 12 12 1, then we can have 2 6 6 2, we can have 3 4 4 3. These are all the possible choices for A and B. Yes, these are. You can also take then minus, just a sec, -1 -12. Just with the minus signs, take each of these cases again. So solutions will be A equals to 1 and b equal to 12. This is one solution, this is second, this is third, this is fourth. Similarly, we have total of 6 solutions. Okay, but if we had known what GCD of A and B was, suppose if we somehow from somewhere else we can calculate or figure out that GCD of A and B is 1, this would make our life very easy. Why? Because now this case is discarded, this case is discarded, this will still be there, this will still be there. We now only have to deal with 4 cases. We have 4 solutions now. Why am I saying cases? Because generally you will not be given single digit terms here. What you will have is something like this: 4x plus 1 plus 3y, then 4x square plus 2y square is equals to 12. So then you'll have, this will be 1, this will be 12. So then you'll have to, this is case 1, this will be case 1. I'll show you exactly how it's going to be. So suppose this was our question. So one case would be this and this. So then we'll have to solve 4x plus 1 plus 3y 1 and 4x square plus 2y square equals to 12. We'll have to solve this equation now. Then we'll have to take up case 2, case 3, case 4. So this question will become very lengthy. What we want is to cancel out, get as less cases as possible. We don't want many cases, we only want very few cases. So that's why knowing the GCD could help. If we had known GCD of these two terms is 1, GCD of 4x plus 1 plus 3y and 4x square plus 2y is 1, then this will make our life a whole lot of easier, because then we'll only have to do with these 4 cases. Though still it's little tough, but at least we're getting rid of those 2 extra cases. Instead of dealing with 6 cases, now we only have to deal with 4 cases. So this makes our life a little bit easier. I think now you get why GCD can be helpful. Knowing the GCD can be helpful. Okay. And this was the method of factorization. Now let's see how this creating square method will work out. So again we will have, I'm just writing here a and b, a square b square, but actually we're going to get a long term whole square plus this whole square, something like that. But for simplicity I'm only taking one, a and b. Suppose we were going to solve say this. Now we want, this can be solved with hit and trial. We want 2 square numbers whose sum can be 13. So we know we have these many square numbers. The moment we go beyond this, we can't have any solution, because if we take a equals to 4, then it will alone be 16 and plus some positive integer. That can't be a solution. So we see we only have one solution. For a can be 4, b can be, b square can be 9, and this one interchange them. So we have 2 cases, case 1, case 2. From here we get a equals to plus minus 2 and b equals to plus minus 3 from here, and from here get a is plus minus 3 and b is plus minus 2. Again, so we only want numbers on the right hand side. If we were given some like 13c square, now still something can be done. Of course, it's not like this is totally of no use, but you see, having this is much easier or easy to solve than having this. So we always going to prefer this one, a number alone on the right hand side or left, doesn't matter. So using these two methods, we're gonna solve these 7 problems now. So let's take up problem number 1. Solution 1. We are given this term. We want to find all integer solutions. X and y belongs to a set of integers. So let's solve this. Let's try to factorize it, sorry. As we want two numbers in multiples, in multiplication, like we had in our previous example, two numbers in multiplication. These two numbers can also have, just like I explained you earlier, can be bigger terms also. So let's try to factorize it. So here we can factorize it in this way. Take x common, you'll get y minus 4. Here do what? Write 4y plus 16. Add 8 both sides. This way we'll have, take minus 4 common. This way we can factorize it. It's going to come out to be this. Now, just like how we did earlier, we are going to we're going to look at each possibility. This can be 1, this can be 8, this can be 8, this can be 1, 2, 4, 4, 2, and minus 1, minus 8, minus 8, minus 1, minus 2, minus 4, minus 4, minus 2. Okay. This one gives a solution. X is 5, y is 12. And this one gives x is 12, y is 5. This one gives x is 6, y is 8. And this one gives x is 8, y is 6. This one gives x is 3, and y comes out to be minus 4. And similarly, you can calculate for the rest of these 3. So we'll have these many solutions, or total of 1, 2, 3, 4, 8. 8 solutions for this equation. This equation has 8 solutions. Okay. So this completes our question number 1. So I think now you've got how this factorization technique is going to be used in solving Diophantine equations. So let's take up an example which will involve creating whole square. Let's take question number 5. Solution of 5th. Here we have x square plus 4x plus y square plus 6x equals to 7. We'll try to create whole squares, and you can see how this can be done. We can add this as 4x plus 4. I will add 4 on both sides. Here I will also add 7 plus 4, and here we write 4 square plus 6x plus 9, and also I'll add 9 here too. And why have I done this? Because this will give us this will make whole square. X plus 2 whole square plus y plus 3 whole square. This gives 20. Okay. What are those two numbers whose square add up to be 20? It is nothing but 16 and 4. So this term can be 16, this can be 4, this can be 4, this can be 16. We only have these two possibilities. Okay. So now this first one gives us x plus 2 is plus minus 4, y plus 3 is plus minus 2, you see how are we getting this plus minus 4? Let me just get it. This is 16. We take square root on both sides. we get, now from here we get plus minus 4. So this gives plus minus 4 minus 2, and here we get plus minus 2 minus 3. So in first case, taking plus sign first, when we take plus sign we get 2, and when we take minus sign we get minus 6. Similarly here, when we take plus sign we get minus 1, when we take minus sign we get minus 5. And similarly you can calculate what will come out of this case. Here you can have all combinations as answers. You can have just a sec. You can have x equals to 2, y equals to minus 1 is one answer. You can have x equals to 2, y equals to minus 5 as another answer, and then x equals to minus 6, y minus 1 third answer, x equals to minus 6, y equals to minus 5 as the fourth answer. So these are the 4 answers that we are getting, and from here also you have 4 answers, so in total there will be 8 answers. You can handle this case on our own. Okay, so that solves our problem number 5th. So from this you've got a clear understanding how these two methods is going to be used. Here we have only done 2 problems. In the next video we're going to take a look at all our remaining problems.